the circuit, each of the 3 bulbs is identical. What will the reading be on the voltmeter in circuit 2 if each cell can supply 4 volts? Each cell supplies 4 volts. The cells are connected in series, so they are all pushing together. So the total voltage supplied by that battery is 4 plus 4 plus 4, 12 volts. Remember that the voltage that the battery or cell gives means the amount of energy that the cell gives to each group of charge as those charges move through the cell. In this example, each group, each coulomb of charge, gets 9 joules of electrical energy as they move through the cell. That's why the cell has a potential difference, which we can also call a voltage, of 9 volts. In any circuit, all the voltage that the cell or the battery gives to the charge must get lost as the charges move through the resistors. So as these charges move around the circuit, they have to lose all 9 volts before they are allowed to come back into the negative terminal of the cell. Because when they go through the negative terminal of the cell, they have to have 0 volts. So the voltage put into the circuit by the cell or battery must equal the voltage that the resistors take out of the circuit. If we have more than one resistor in series, like here, then the voltage is shared between them. If the 2 resistors don't have the same resistance as one another, the more difficult resistor is more greedy for voltage, because the charges have to struggle more as they go through the more difficult resistor, and that takes more voltage out. But in this circuit we have here, all 3 bulbs are equally difficult, equally resistant, because all 3 bulbs are identical. Remember, there's the rule that the voltage that the battery puts into the circuit must equal the voltage that the resistors take out of the circuit. Notice the ammeter doesn't take out any of the voltage, because an ammeter is like a good conductor in that its resistance is 0 ohms. So it's very easy to go through an ammeter, just like it's very easy to go through a good conductor. It doesn't take any energy to do that. It doesn't take any voltage to do that. So no voltage is lost as the charges move through an ammeter. No voltage is lost as the charges move through the good conductor. And a voltmeter also doesn't take any energy. It's just feeling the difference in voltage, the potential difference, or the voltage across the 2 points that we are measuring. It doesn't actually change what that voltage is. So the only components which can take the voltage out are these 3 bulbs. And together they have to take out all the voltage that the battery put in. They have to take out 12 volts. Because they are all identical, those 12 volts will be shared equally between them. So each of the bulbs will have a voltage of 4 volts across it. In other words, each of the bulbs will have a potential difference of 4 volts across it. That makes 12 volts altogether. 12 volts have been put in by the battery, 12 volts are taken out by the resistors, by the bulbs.